Hey y'all, happy Sunday. Hope everything is going well for you and yours. This is the portion of the show where we let YouTube send out the notifications via social media, let folks know that the broadcast is getting ready to start. We'll sit here and we'll count down the next 2 minutes before I push that button and go live. If you happen to be watching this on replay, go ahead and scrub past this graphic until you see my smiling face. If you have any questions and you're joining us today in the live chat, feel free to go ahead and add those questions to the live chat now, and we'll get to them in due course during this live Q&A session. So, sit back, relax, grab a beverage, and we'll get going in about 30 seconds. Hey y'all, happy Sunday. Hope everybody's doing well today. Hope you and yours are all fine. We're getting into that time of year. We're getting into that time of season. And once again, real life jumped up and grabbed me you know where. And I was not able to get a video edited and get it out this weekend. So I apologize for that. Right off the bat, let me go back up here real quick and say to IL Peleg, thank you very much for your super chat, sir. I appreciate your support as well. You've been here from the get-go. I don't think you have missed, you might have missed one or two of the live streams, but you are one of the good guys who always right there every time, all the time. I really appreciate it. Let's see. I guess the big behind the scenes news here at Chaos Central is so many things have been going on here that I have the CNC table leveled. I'm now getting ready to, I'm going to change over the mount a little bit so I can tram it a little bit better. I posted a video online a few years ago when I built this CNC router, about tramming the router in and making sure it's cutting straight. And since then, I have upgraded to big boy toys and went ahead and got the Edge Precision mini tramming setup, and I will be using that to tram the router this time around. I'm almost, but not quite ready to do that. I'm kind of stuck in the middle in what I tend to call the long, dark tea time of the soul, in that when I tram the router and surface my spoil board, it's going to create a ton of dust. And right now what I'm doing is I'm busy working on a dust collection cart, which will be temporary, using a shop vac. It's a temporary solution. So I've got to CNC cut one part for that, so I can set up dust collection so I can use the CNC without screwing up my shop. So it's all kinds of goofiness going on. Rick French is saying, this is what happens when you have too many computers on one table. I'm just using the other mouse. Rick French is saying as a link for a tramming tool that you just showed us. I will put a link in the description as soon as we're done live. There, I just wrote myself a note to put that down. They run about right around $100. But the number of hours that they will save you from doing it the way I did it in that previous video, swapping back and forth and everything, having two dial indicators right there that you don't have to keep swapping back and forth and doing math in your head and figuring out. To me, time saved is money well spent. So we'll see. I will put it will be an affiliate link. But I'll put that in the description as soon as we're done live here. I have forgotten a couple of links. Well, no, I did not forget one link. Michael Mazalik will not be doing a video this afternoon. He will not be premiering one. He's taking what he has called a family holiday. So he didn't get a video edited and posted. So there won't be a video this afternoon on his channel, but he says look for him to come back next week. So let me see. Let me cruise up here to the top. We had a little bit of I don't know if you would say controversy, but YouTube is not very good at anticipating the time change. Here in the US, we went off of daylight savings time overnight last night, and YouTube, the countdown timer on the YouTube page was an hour ahead of schedule because we set the clocks back an hour. So, it was giving incorrect time and saying that I was going to be starting an hour sooner than we actually did. So sorry for any confusion that that may have caused. So we will be, running, here at, as usual, noon Pacific time in in the US, 3 p.m. Eastern, and I believe that is 8 p.m. Greenwich Mean Time. I don't know. There is a universal standard time, I believe, but I don't know how many people actually use that. So, okay, big question here from John at Wood If I Could. Why are all Oreos not double stuffed? My question to you would be, how do you know they're not? I don't know that any of us know what the original stuffing was on an Oreo. Maybe they are double stuffed as compared to what they used to be. Just one of those things that make you go, Now, for other questions, Isle Peleg wants to know, can you talk about spindles versus routers, pros and cons of each? Also, are e-spindles water versus air cooled? It's interesting that you bring up spindles because I was just talking with a friend, in fact, Martin, the gentleman who built my shop shed. That is one of the first upgrades I want to do here on my Gatton CNC is switch from the router to a spindle. They both have their pros and cons. They both have their advantages and disadvantages. The advantage of a router is they're cheap, they're readily available. You can pick up a router just about any place that sells tools. They can be ordered online. And with international shipping now, I know for a while in some markets, finding a router that you could take the motor out of the base to put into a CNC router was kind of difficult, but that's less the case now. So with a variable speed router especially, you have some flexibility there, and there's a lot of well, I'll just call it instant gratification in that you can get one now. They're also very cheap to repair. Usually, about the only repairs a router will ever need over its lifetime will be replacement of the brushes, possibly a bearing here and there. And they're not expensive. I have a second set of brushes for every router that I own. And I think the most expensive set was somewhere around $18. So, and bearings are priced accordingly, anywhere from $15 to $16 each. So you can generally, and I'm a Porter cable router fan. I was devastated when the parent company decided not to make them anymore. But I know people using 30-year-old Porter cable routers every day in production shops. They're just workhorses. You blow them out at the end of the day, replace the brushes when they wear out, and replace a bearing every blue moon, and they'll outlive us all. Spindles, on the other hand, have the advantage of further control, better control than a router ever would have. You can slow a spindle down a lot slower than you can slow down a router. And that matters on certain materials like plastics and some metals where you want something, 6 to 8,000 RPMs, where a router just won't run that slowly. I'm using a Porter cable 890 series router motor in my CNC right now, and it will go down to 11,500 RPM, but that's as low as it'll go. And that's still too fast for some plastics. That's why I've never cut acrylic on my channel, because I can't get that dialed in just right, because 11,500 RPM is just too fast. It builds up heat too quick. And it's the wrong RPMs for certain metals as well. That's why I've never tried to cut metals with it. The spindle, generally speaking, has more torque, and they are brushless. You are going to get a much cleaner cut with a spindle than you are with a router. Routers are made to be handheld or used in a router table, and the level of precision is not quite as fine on a router as it is on a spindle. Spindles are made to be precision instruments. There are precision tools, where routers, the tolerances aren't as close on a router. You will get a lot more run out on a router, meaning that the bit, the shaft with the collet on it may not spin perfectly concentric. There may be a little bit of play in there. There may be some run out in there. It's not going to be a huge amount, but run out of 0.02 of an inch could be a big deal. Spindles are torqueier. They are much, much easier to control. But one of the disadvantages of a spindle is, in the US, this is not as much of a concern overseas, because you basically are on 240 volt power anyway. Most routers here in the US are 120 volt, which are made to be plugged into a standard wall socket and can be run in just about any shop or garage. Not everybody here has 240 volt service. Now, I do. And in fact, I've dedicated a circuit right here to add a spindle at 240 volt. So there is that as well. So it may require, getting a spindle may require you to have an electrical circuit added to your shop or garage so you can run one. Another advantage, and this is one thing Rick French is asking about now, can you control the router speed in Mach 3 or Mach 4 like you can with a spindle? It is easier to do with a spindle, but it can be done with a router as well. You have to get what they call a PWD. And basically the PWD, which I believe is pulsed, oh my gosh, pulsed width drive. I don't remember what PWD stands for. Anyway, you basically, Mach 3 controls the PWD, which controls the speed of the router. So it can be done, but you're buying another big piece of equipment. So you've got the router, then you've got the PWD to be able to control in Mach 3 and Mach 4, when if you took the price of those two, you could buy a spindle for much less. So, if you're thinking about going with the spindle at all, you'd be much better off going with a PWD IL. He's asking PWD or VFD. VFD is a variable frequency drive. That's what that is that's used to convert the the single phase power we're using in our homes to three phase power, which runs the spindle. Because a spindle motor is actually three phase, which is industrial and gets real expensive and everything else. In fact, most electric companies will not run three phase power to a home, and you wouldn't want it anyway because it's outrageously priced. There it is. Brooks Martin says PWM. That maybe that's it. I just I can't remember. I looked into them about 5 years ago when I first started using the router in my CNC, which was going to be temporary then. And I just when I figured out how much it was going to cost just to get that all set up, it didn't make any sense. I just decided I would go ahead and go with a spindle. Now, as far as air-cooled versus water-cooled spindles are concerned, it's kind of your choice. They both have pros and cons. The air-cooled is going to blow air, suck in from the top and blow it down through the bottom, the same as a router does. So you are going to have dust flying. But if you're using proper dust collection like you should, that shouldn't be an issue. The advantage there is you don't have any water lines to potentially leak or freeze. That's the other thing about it. I'm going with air-cooled simply because I don't want to hassle water-cooled. Now, I know a lot of people use water-cooled spindles, and that's great. This is one of those cases of it's personal choice. Do you want your truck to be blue or green? It's 100% up to you. They're going to perform well no matter which way you go. Personally, I just prefer the air-cooled route because it's one less complication to go wrong. 8 Sinner is saying, how often do they actually leak, though? Depends on the person and depends on how you installed it. I mean, true. I mean, your point is well taken. How often do they actually leak? I just know my luck. If there's a way, it'll happen to me. If I take off my right glove and it's 40 below zero, whatever I'm looking for is going to be in my left pocket. Okay? That's just my luck. That's what it's like to be me. Rick French brings up a point here. Water-cooled is quieter. Spindles are quieter than routers. However, after talking with people who have run both spindle and router, every single one of them will tell you the same thing. They're all just the same noise level the minute that bit starts carving. Because no, you don't have the whine of the router, but that bit carving the material is the loud part. I mean, and I can tell I can't hear the router over the bit carving the material when I'm cutting here. I mean, I can tell that it's there. I can hear a little whine in the background, but the spindle motor itself is quieter. My main reason for wanting to upgrade to a spindle is for the controllability and for the torque. I mean, because spindles they produce more torque than a router ever would. Another thing to consider is a variable speed router. You are limited. If you have a single speed router, you can go get cheap router speed controls. I mean, I've got one, but you can't use those with the variable speed router because it will burn out that router control board. If a router speed controller works by adjusting the amount of voltage going into the router itself. You can't you can't be doing that. It will burn out that control board. Don't ask me how I know that. Let's see. 8th Center wants to know, is there a torque difference between water and air cooled? I would imagine that would depend on the brand and manufacturer, and I would bet that there's some variation there, between different brands and setups. I'm not aware of a torque difference in water cooled versus air cooled. And I know there are some people who live in very hot climates. That need water cooled. I mean, I have a couple of friends down in Texas that, I mean, we're talking temperatures over 110 degrees commonplace. So, water cooled is a big advantage for that. I mean, we have days over 110 degrees, but with the insulation in this shop and the air conditioning, I'm fine. So I hope that answers that about the router versus spindle. Again, they both have advantages and disadvantages, but it's kind of sort of like building a race car. Speed costs money. How fast can you afford to go? So let's see here. We'll get back to some of the other questions. Robin wants to know, howdy, Robin. There was an add-on right before the live intro started, and the guy talking sounded just like you. Was that you? No, unless they took audio from some of my videos and spliced together an ad using my voice. It was not me. I have not done any kind of radio or advertisement work other than anything that's on my channel or, a couple of friends or what have you. So, let's see. Getting back up here. And alrighty, there we go. Richard Kenton says, can you describe allowance offset? It seems backwards from how I think about it. Okay, let me bring up, let me go ahead and share my screen here and bring up Aspire. And we'll see if this is what you are talking about. Over here let me hide that, sorry. Over here in, I believe it's a pocket tool path. No, there's the allowance. It's pocket allowance. Is that what you're referring to? I'm trying to remember which tool path you got whoops. That was a mistake. That's not what I meant to do. See here. Was there an allowance offset in material setup? No. Is there one in 3D roughing? Where are we finding allowance offset? No, that's a well, I'm trying to think of where the allowance. Let me go back over here and look at you all in the chat and see if anybody can remember exactly where the allowance offset is. I know the pocket allowance in the pocket tool path is either how much larger you would like for that pocket to be or how much smaller you would like that pocket to be. Okay, Todd HCNC says it's in the profile tool path. Is there an offset? There is an offset allowance. Okay. That's where it is. Thank you very much, Todd. I really appreciate it. Todd's another one of the good guys, by the way. I do wish he'd put out some content on his channel. But, you know, Dave and I have been after him to do that for a while. So what can I say? Thank you very much, though, Todd. Okay, offset allowance. All right. The offset allowance is based on what you're doing here in your machine vectors. Whether you're cutting to the outside, the inside, or on. Okay. So let me close this, put some geometry out here, and I'll just do a real quick rectangle just for giggles. All right. So close that, and I'll come over and we'll calculate a profile tool path, and I'll do this to the outside with no offset allowance, okay? Just to show you what it's doing. And scroll down here. My mouse is extremely, yes, I know it's going to cut through. My mouse is extremely slow. All right, we have that tool path calculated, and it is selected. Now, if I come up here to toggle the tool path 2D drawing visibility from wireframe to solid, then go into my 2D view. Come on, where are you? Well, something's not right. What it should be doing is it should be drawing. Oh, no, there it is. Wireframe or solid. Good grief. My mistake. If we look at the tool path, this is where the bit is going to go. I mean, that is showing you what the tool path is solid. It's going to cut right there on top of that line. So if I close that and come back into my profile and I use a positive offset allowance, let's go for a large number. I don't know what the smallest or the largest it'll let me do, but let's use a 0.1 offset allowance. And that's a positive number. And we calculate, jump back over here to the 2D view, and we see it is cutting that profile larger. But also remember, I'm cutting to the outside of the vector. If I cut to the inside of the vector, let's go ahead and switch that. Come on, mouse. Calculate. And jump over here to 2D view. It makes the profile smaller. Does that make sense? Basically, it depends on whether you are cutting to the outside or the inside of that vector. A positive number, if you're cutting to the outside, it will, whatever you set your offset allowance to, it'll cut outside by that distance. If you're on the inside, it will cut to the inside, that difference. Now, if we do a negative number here, a negative 0.1, cutting to the inside, and calculate, it'll jump over into the preview. I come back over to the 2D view, and it's actually the center of the tool is cutting that 0.1 over. So you see what we get. Almost, but not quite on the tool, on the vector. So you said it seemed backwards to you. Is that what you were actually trying to say? What you were trying to figure out? Now, if I go to the outside, machining to the outside of the vectors with an offset allowance of 0.1, a negative 0.1, excuse me. And it too cuts to the both inside and outside. Excuse me, it doesn't put the center of the tool. It puts the edge of the tool, that 0.1. So is that any help to you there? Was that what you were asking? Okay, 8 centers. So why would you use an allowance if you're already planning on cutting to a measurement? Why not just change the measurement? Is this used for cutting inlay parts or something? There are certain, and that's a good point. That's a valid point. I don't use it personally. I've never come into a situation where I have needed to use an allowance. There are certain specialized times where you would need them. I see, let's see, who was it? Somebody else, I can't find it, had said that it was in the inlay tool path as well. But basically, wow, I can't think of a situation off the top of my head where you would need it, but I'm not a machinist. So I would guess if you had to leave a little bit of extra material to make absolute, or to compensate for something else, you would use it. But personally, I have never used that offset allowance. I haven't needed it because, I'm with you. If I need it to cut 0.266, I'm not going to draw it with, 0.25 and then add a, 0.066 offset. I'm just going to draw a 0.266. So now Marcello Ballone says that he uses an allowance in Fusion 360 when doing a straight inlay. That I can see where you are drawing. Okay, that would be a good example there. Thank you very much for that. If you were doing a straight inlay, not a V inlay, but if you're doing a straight inlay, you could draw one vector and use that vector for the male and female. So that, anybody who's ever tried can tell you, you cannot put a 1/4 inch dowel in a 1/4 inch hole. One of them the hole has to be larger than a 1/4 inch, or the dowel has to be smaller than a 1/4 inch. You cannot force that fit. So using that offset allowance to make something slightly smaller or something slightly larger, I could see would make the male fit into the female using an inlay without having to draw up totally different vectors. I see that now, and that does make sense. I see that makes sense. Richard Canton says, I think it helps in case your tool is not the exact measurement as stated. There could be something to that, but I don't know about that. Yeah, I'm not sure. Because generally speaking, unless you're using it to drill a hole, for instance, if you're using a 1/4 inch end mill and you tell it to pocket a 1/2 inch hole, it's going to pocket that 1/2 inch hole, whether your 1/4 inch end mill is actually 2.48 or 2.51. Still, I could see where it would be an issue, but a slight issue. But again, if you're doing woodworking, we're not looking for 4-digit precision. We're not even looking technically for 3-digit precision on most things, because in the case of and Marcello could probably be a better judge of this than I am, but just the moisture from the glue is going to cause those wood fibers to swell more than that 0.02 of an inch anyway. I mean, maybe I'm wrong there, Marcello, but I'm used to building with a 1/16 of an inch builder's tolerance. Okay. So I'm the wrong person about getting it absolutely 100% spot on perfect. So let's see here. Trying to go back up here to these questions. Let's see here. Andrew Perry wants to know, is there a way to adjust the height of your Z when using a probing block? The problem is with the smaller bits, they hit the shank first. I'm not exactly certain what you mean by a probing block. Do you mean a touch plate? Because I've not heard a probing block before. And again, I'm not an expert. So smaller bits, they hit the shank first. What I have seen a couple of people do, I've never done it myself, so take this for whatever it's worth, is put the bit in. I wish I had a bit. Well, I do have a collet, but I don't have a bit for it handy. Put the bit in the collet. Well, yes, I do. And it's a 1/2 inch bit and a 1/2 inch collet. What do you know? What I have seen some people do is slip the bit into the collet and leave it loose, bring down their Z until the bit just starts to slide in that collet. Stop, tighten everything down, set your Z0, and that's it. I'm not suggesting you do that. I've seen it done that way, though. There should be a way to get that, and I know what you're talking about. You're talking about some of those micro bits. Setting Z0 on those can be problematic because they're so tiny. And we're talking about bits so tiny that if you attempt to use a touch plate, you'll shatter the bit because the system can't react fast enough. Those things, they'll shatter just looking at them wrong. There's a gentleman over in Australia that I have referred to before. He's John with Labels Extreme. And he is one of those people that does that. He'll put the collet up into the router loose, or the spindle rather, slip the bit up in there and then finger tighten it. Then bring down the Z until the tip of the bit touches the material and the bit starts to slide. He'll stop, set Z0, and tighten it up with the wrenches. I'm not telling you to do that, but that's one way I've seen it done. So if I can quit grabbing the wrong mouse, I hope that's a little bit of help for you there. But generally speaking, yeah. So, okay, let's see. Let's go on here. Okay, IL Peleg says using the allowance offset would allow you to keep clear of the profile you're cutting, then come again removing just a small amount to have much less deflection. Yeah, there is that as well. And what he's talking about is, and it's fortuitous that I have this here, I can just keep from cutting myself with it. If you're using that allowance offset to cut, let's say, a 1/4 of a millimeter away from that vector, you can then calculate another tool path to come in with 0 allowance offset and cut right on that vector. And the tool, especially if you're using a small tool, will have less deflection. I would also, though, say, that's what the separate last passes for. You could set that as well, and the machine lifts the bit completely out of the material, moves in that amount you had set for your separate last pass, then ramps in and cuts the piece of material in one last pass at exactly that on that vector. So, but yeah, there is more than one way to get the job done. So, okay, let's see. Let me scroll up here. How are we doing on time? We're looking at 40 minutes in. Let me get up here and see. Let's see. John Thompson is doing a 3D carve of a design and make. The arrival, it is a 9-inch by 9-inch. Is it better to use a 16th-inch tapered ball nose versus an 8th-inch ball nose for greater detail? Well, the smaller the bit, the better the detail. I mean, that's just a rule of thumb. Also, the more time it's going to take. Now, I don't know if you have version 11 or not, but version 11 has rest machining built in to its 3D finishing toolpaths now. So you could use both. And what the toolpath will do is it'll calculate one toolpath for that 1/8-inch ball nose and let it carve everything, and then switch over to that next toolpath using the 16th-inch ball nose, and it'll just go back and get the details that the 1/8-inch ball nose can't reach. So 9-inch by 9-inch, depending upon the level of detail, an 1/8-inch ball nose may be all it needs. Then again, if it's got a lot of detail or a lot of deep engravings or a lot of relief, you might need that 16th-inch tapered ball nose. You're not going to like what I'm going to say. Practice in scrap. I mean, try it in a piece of scrap material. It's prototype. Consider it prototyping. And the only problem with prototypes is we have a lot of prototypes around our house because I make the prototype, it works, why build another one? That kind of thing. But yeah. So what can I say? But again, it's going to depend on personal taste. You may think that the 1/8-inch ball nose is enough detail. I mean, it depends on the project. Is it going to be something that you're going to hold in your hand and look at up close? Is it going to go up on a wall 16 feet up off of the ground? How far away is it going to be seen from? You're the best judge of how much detail you actually need. And if an 1/8-inch ball nose will do it, great. If it won't, then you may consider, I mean, heck, a 16th-inch ball nose may not be small enough. It just depends on how much detail do you want. So let's see here. Let me go down here. Martin Pearson says design and make models are designed to give maximum detail with an 1/8-inch bit when imported at the size they are made, which is generally 6-inch. So all you will do is waste time. Maybe, maybe not. I mean, I've seen some pretty detailed stuff coming out of design and make. And again, that's pretty subjective. So let's see. Getting back down into the routers. David Pingle says, according to several YouTube presentations, they are recommending running at 18,000 RPM, but taking shallow cuts. I thought that was fast. It is for certain materials. I mean, and that's the thing. My personal default setting on my Porter Cable 890 router, it's a 2.25 horsepower router. I generally speaking leave it set at about 16. I think it's 16.5. It may be 16.8. And I find that works very well for most cutting. I mean, I do slow it down sometimes. I do speed it up other times. It just depends. The thing to remember is, and even the chip load people, the chip load calculators and the tool manufacturers will tell you that is a suggestion. It's a recommendation. You have to dial it in yourself. They cannot account for how robust a machine you have or the density of the particular material you're trying to cut. You can say hardwood all day long, but is it a dense hardwood? Is it a light hardwood? Anybody who's been working with wood for more than a week or two will tell you that poplar and maple are both hardwoods, but that's where the similarities end. There is no way you're going to cut poplar and maple at the same feed rate, spindle RPMs, and get the same results. They're different materials. Maple can have 3 or 4 different densities in the same square foot of material. Those numbers are estimates. The thing to remember is make chips, not sawdust. Listen to your machine. And if you hear something that is not normal, it's not normal. Stop it, diagnose the issue, find out what's wrong. That's why I don't get into feeds and speeds, and I don't get into time estimates. There are too many variables for anybody to sit here and say, use this RPM and use this feed rate. I'm very wary of that because there are just too many variables. So, let's see here. 8 Center says the speeds and flute number thing confuses me a bit, but I do understand that sometimes you can change either to get the right balance. Yeah. As a general rule, I tend to go with single or 2 flute bits, just mainly because they'll evacuate that chip out of there a lot quicker than a 4 flute bit will. It'll throw that chip out of the cut before the next flute comes around and cuts that chip again. Personally, I don't use 4 flute bits in wood. I mean, because in essence, if you take a single flute bit and you're running it at 600 RPM, let's just use that number for giggles, okay? You use a 2 flute bit, it's got 2 flutes going around at the same RPM. You are effectively increasing the RPM of the number of cuts per minute. You're doubling it. So the motor is still spinning at 600 RPM, but instead of that single flute making 600 cuts per minute, you've got 2 flutes making 1200 cuts per minute. Now you go with 4, suddenly you have 2400 cuts per minute. And if your machine isn't moving fast enough, it's not able to keep up with that kind of a chip load. It's not able to evacuate those chips before they keep getting cut again and again and again, which builds up heat, which then starts burning. And I don't mean it's going to burst into flames and burn your house down. I don't mean that at all. I mean, you're going to start seeing discoloration and smelling stinky wood. So, yes, Marcello. I keep grabbing the wrong mouse. I need to put this down in a drawer somewhere. Marcello says, reduce the cut load by the number of teeth. Exactly. So, sometimes it's real easy to get caught up in the jargon there, 8 Center, and I do it too. I have a hard time remembering that I'm supposed to be talking to people who have never done this before, but you can't get away from jargon. It's a thing with me. I have saying the wrong word is my thing. I will mean the word relevant, but I'll say the word relative. It's just what it's like to be me. Let's see here. let's see, get down here to okay, yeah. 8 Center says, I'm still saving towards my Shapeoko XXL Pro. Haven't decided on a spindle type yet. I mean, a lot you've heard buy once, cry once, and you've probably heard, like I just said, speed costs money. How fast can you afford to go? I would say you are going to get probably better service with a spindle. But I understand budgets. Just go for what your budget will allow. Go for what your budget will allow. I mean, if it means you have to save up for a couple of weeks or a couple of months more to get a spindle versus a router, you may be better off going that way. But then again, compare them. I mean, if you're looking at the difference between a 1 horsepower spindle and a 2 horsepower router, that's something that you're going to have to decide for yourself. Only you know how you plan on using your machine. Generally, a spindle is the better way to go over a router, generally speaking. So let's see here. Dave Blackburn. Hey, Mark, I'm building a surface sander with a 4-inch drum. Could you give me some suggestions on how to carve a sloped, curved edge to fit the drum for the bottom of it, about 70 degrees in 3/4 MDF? You're using V-carve. A sloped curve edge, draw the profile and use the molding tool path. That's about the only way I can think of to do it in V-carve. If you had a spire, there are about 10 different ways. I would. Okay. Yeah, I would draw the profile that you're trying to achieve and use the molding tool path. Let's see. Trying to cruise down here. I know the questions are way up in the chat, but you guys have some good questions. So let's see. Okay, here's Camilo Amaya. Camilo Amaya. I'm sorry, I butchered your name. I apologize. When making a tile tool path, why would the pieces not line up after routed? I had 3 pieces, 47.5 wide by 95 tall. When I put them together, each piece had to be raised by a 1/16 inch in order to match. That could be any number of things, Camilo. It could be an improper thickness. Did you measure the thickness of each sheet when you cut it? Excuse me. Excuse me. If you're using something synthetic like a high density urethane foam or sign foam, something like that, generally speaking, their thicknesses are pretty consistent. But even on something like Baltic birch plywood, or especially a hardwood or softwood, minor inconsistencies can cause that issue. Another thing to look at is how secure your collet is in your router. Did it slip? Did it move slightly? Are you using a touch plate to set your Z0? Are you getting a good consistent Z0 every time you set that Z0? Could your Z-axis be losing steps? Do you have a belt that isn't tight, or a coupler that maybe not quite as snug as it could be? I always check the mechanical first, because 99 times out of 100, that's the issue, and it's nothing to do with the software. That's not to say that that is the issue, but the first things I would look at would be how consistent the thickness of the material you're carving is, how consistent you are with setting your Z0, and then look at the machine itself. Is something loose? Is something not quite as snug as it should be? Because a 1/16 of an inch, That's when you're talking about something that large, that's quite a bit. Could also be maybe you need to resurface your spoil board. It could be any number of variables. But generally speaking, I always check the mechanical first, then go to the software last, because when you're talking about a machining issue like you're having, usually it's not the software. It's almost always something physical or mechanical on the machine. So let's see. Jack Matson, thank you very, very much for the super chat. You guys are absolutely dynamite. Oh my gosh. Thank you so very much. I mean, I can't, I don't know what to say. I mean, good grief. Thank you very much, Jack. Let me see. Let me go up here. I'm trying to find these questions. And, my wife has suggested many times that we get a host, a guest host, or a co-host, excuse me. Couldn't think of the word. Okay. I see. I'm sorry, Camilo. You're not talking about Z thickness. You're talking about, it's almost as if the X0, Y0 had shifted with each sheet and been raised on the Y-axis by a 1/16 of an inch. Definitely look at your axes. Look, you should be setting your X and Y0 on each sheet as you mount each sheet. I would be looking at, you see, it looks like it's been raised on the Y-axis by a 1/16. I would check the Y-axis and make sure there are no loose couplers, no loose motors. If it's shifting up in Y, now I don't know if you have a stepper on each side of your Y-axis, or of your gantry, I should say, that moves on the Y-axis. I don't know if you have a stepper on each side or if you're using servos or what you're using. Check them both, because one may be lagging slightly behind, or your gantry may be slightly out of square. That would not account for it getting progressively worse. I would still check the physical. I would check the machine and make sure that you're not, I would check the machine. So I'm sorry. I thought you were referring to the Z axis. So let's see. Cruise back down here and see if you're Dave Blackburn. Holy cow. You're another superstar. Thank you very much for the super chat. I appreciate it. Let's see. Todd for Freedom says, my biggest point would be these PWM boards that control speed can fail easily. Yes. And they are expensive. Yes. And long lead times. I would definitely go with a spindle if you can afford it. Yes. Yes. I would agree with that. I mean, there are people all over the world that use them. The PWM, PWD, whatever you want to call it. But there are people all over the world that are still using Fanuc machines. So, it's definitely a trade-off. I would go with a spindle before I went with a router if I had to do it all over again. So, what can I say? That's just me. But I don't think you can go wrong with a spindle. My main reason for wanting to go with a spindle, to be honest with you, is I want that router back. I mean, that's my main router I want in my router table. I've got 3 other routers that I can use for handheld routing, but I want that back for use in my router table. So, okay, I'm going to go ahead and end this now. Brooks Martin has a good suggestion. Maybe use a fixturing jig for your setup there, Camilo. And Lewis Denton also try to locate your X or Y on dowels. That way you are getting that sucker right in there just perfect. I mean, repeatability is only as good as your location. And yes, you can move stuff all over the CNC table and it should line up. But if you mount a sheet of material on your CNC and then put down blocks, whether they be dowels or you physically screw something down to the surface, to where the next piece can go on in precisely this exact same spot, you're always going to be better off. And that's also why I take notes. I am forever there we go. Do I have audio? I hit the mic cord on the side of my laptop. If my audio is my audio good? No audio, boy. Let's see. Okay, now we have audio. Okay, thank you, IL. I went to pick up my notebook. I forever have my notebook here with me, forever. So, take copious notes, write things down. And if you did one thing, try to do that exact same thing based on those notes. I mean, but the first thing I would do is I would check the machine just to make sure that there's not a problem. So, okay. Let's see. 8th center, a good point. You've been focusing on asking the groups what they ended up with, not what they started with. If you can hold out for a spindle, hold out for a spindle, but I don't know. It depends on how fast you want to get going with it. And I know, believe me, I know this is my 3rd CNC router. When you're in during the build process, you can't go fast enough. And if that means that you spend $150 on a router now, and then maybe I'll spend some money down the road to get a spindle, so be it. Well, but will you? So do it now and buy once, cry once. I know, but what the heck? And I don't know what it is about this hobby. It's hilarious to me. Sometimes folks will say, "Oh man, but that's so expensive." To me, I don't know. I look at tools as an investment, number one. But it's funny to me that folks would say, well, spending $100 on that tramming tool. Well, that's just crazy. I would never spend $100 on a tramming tool. But I'm going to make that back in higher quality work. So it's an investment. It's no big deal. I know people who said they don't want to buy a $40 bit. They'd rather buy two $20 bits. Well, if $20 is a deal breaker, you might want to consider a different hobby because there's going to be an expense. There is going to be an expense. So, okay, let's see. I'm going to go ahead and wrap this up. I do have one more thing to say, and this is the thing that I forgot to put the link in the description, and I'm going to put it in there as soon as we're done live here. And that is my friend Jerry over at his website, Living Beyond Disability, is sponsoring a challenge, contest, competition, however you want to call it. And it was voted on. It's called the Fairy House Challenge. And what they want you to do by December 17th is build a fairy house. It can be out of any material. It can be using any method. The only stipulation is it needs to be able to fit into a 12-inch wide, 12-inch long, 12-inch deep cube. For those of you on the metric, that's a little bit under 305 millimeters wide, tall, and deep. Make it out of any material using any process, whatever you'd like. If you want to make it out of wood, make it out of wood. You want to make it out of papier-mâché, make it out of papier-mâché. You want to make it out of sign foam, make it out of sign foam. You want to make it out of aluminum, make it out of aluminum. But he wants to see pictures. I will put the link to the competition down in the description of this as soon as don't use paramagnetic materials. They don't like it. I will put the link down in the description of this video as soon as we get finished live here. And this is a good competition too. I mean, first prize is, I believe it's a 102-piece tool set. So we're not talking small potatoes here. Jerry's a good guy. His site is Living Beyond Disability. His entire goal is to inspire folks who may have a disability to realize that they can be productive people. They can continue to do the hobbies that they've loved. They just may have to approach things from a different angle than folks without that disability. He's a hell of a guy. It's an excellent cause. I will put links in the description where you can take part and sign up for the challenge. There's only a couple of rules, very easy. And if you'd like to donate for prizes or donate a prize, there's a contact information on that website for you to do that as well. That's Living Beyond Disability. And again, I will get links put in the description as soon as we're finished live here. Now, you only have until December 17th. But then again, if you have a CNC router and a laser or both, I mean, you can whip this out in a weekend. Yes, Ayal, you're absolutely right. Thank you for reminding me. The other stipulation on the rules is you have to give that fairy house away. So, just in time for Christmas. If you know somebody who would like to have a fairy house for their front yard, backyard, side yard, living room for that matter, now's the time to do it because a Christmas gift counts as giving it away. Okay. Another real quick inside baseball here. My channel is now officially on hiatus for the holidays and for me having some dental work done. I will be doing another live Q&A next Sunday, the 14th, and I will have a topic to discuss. I'm going to pick something, fairly simple that we can talk about over the course of about an hour. But there will be no Sunday live stream the following Sunday, which will be the 21st of November. I'm going in for major dental surgery on the 17th, and I will not physically be able to talk where folks can understand me by the 21st. We don't know about the 28th yet, but we'll find out. So there will be a live Q&A session next Sunday. It will be open Q&A, and I will have a topic to talk about. But there will not be a live Q&A on the 21st. So, okay. I want to say thank you very much to everybody. As soon as I get those links in the description, go check out Living Beyond Disabilities Fairy House Challenge and sign up. He's a great guy. It's a great cause. And looks like it's going to be a lot of fun. There's already a few people that have got their fairy houses complete, and you can see pictures of that on the website. I will see you next week, and I'm running through my brain to try to I'm spinning the little wheel on the Rolodex to see did I remember everything. I think I did. Y'all take care. Have a good one. Be safe. And most of all, have fun.